So there are a number of usages for satellites in VLEO of particular interest. If you think about just the distance, if you get closer, right, with your own eyesight, you can see things more clearly. So obviously, if you are looking at observing things on the ground, the closer you are, the more resolution you can get, and you can think about various different applications, from commercial applications to obviously the government. My name is Sven Bilén. I'm Professor of Engineering Design, Electrical Engineering, and Aerospace Engineering at Penn State. Generally, we talk about orbits below about 450 kilometers, maybe down to about 200 kilometers. Those are standard orbits that we've been using for a long time. The ISS is in those orbits. A number of satellites operate in those orbits. What we're really talking about are orbits that begin to get even lower and lower, down to the point where atmospheric drag really takes over, and that makes it very hard to maintain the orbits of those satellites. That means we actually have to be thrusting constantly. You're really trying to do something that's very, very difficult. You're trying to thrust at a level that is beyond the drag that's currently occurring. However, you also have a resource that's available. If you have atmospheric drag that's pulling down your spacecraft, well, what if you were able to collect that atmosphere, use that same atmosphere as the fuel for your thruster, and then use that to push? That's really the promise of thrusters in VLEO, is that they can use the atmosphere that's slowing them down, but collect it, do something to it, such that it is then the thruster. I could see that we'll continue to come lower and lower over the next 3 to 5 years, maybe for for full systems that are mission ready. It would come after that. But that of course is with respect to the kind of investment that's willing to be put out there by both the government and by industry. The ability to essentially launch them much more rapidly, because you don't have to get up to such a higher orbit. You can launch them when emergencies happen, or natural disasters, or from a defense standpoint, a war breaks out or a new conflict breaks out. So there's a lot of different applications that way. You can also look at communications and communication delays. And so when you send a signal from your cell phone, it travels at the speed of light. And so if it has to go into orbit and back down to orbit, there's going to be a slight delay. And so the closer that you can be to the Earth, the shorter that delay will be. I think from a consumer standpoint, the ability to have essentially global coverage with their cell phones, so essentially if they're out in the middle of the ocean or on a boat or something like that, having this much lower means that their cell phone will have the power to be able to reach up to the satellite, etc.